This example asks us to find the magnitude and direction of the resultant of the forces 3 newtons and 2 newtons acting on the particle O as shown in the diagram below. We have two ways of doing this. One way is to use the unit vector notation. The other way is to use the sine or cosine rule. For this part, I'm going to use the unit vector notation. Horizontally, I have unit vector I. Vertically, I have unit vector J. We have the two forces drawn in the diagram. One has been labelled with an endpoint of A. So if I drew that force in, dropped a vertical line down to the horizontal axis and took it across, what I have is a right angled triangle. I am told that on that right angled triangle from the diagram that the angle made with the horizontal and the vector is 30 degrees. And I know the magnitude of the vector is 3 newtons. So the magnitude, the length of it is 3, which means that I can now express the horizontal and vertical sides. The horizontal side is the adjacent side on a right angled triangle. We know that the adjacent side on a right angled triangle is associated with cosine. So the length of that side would be 3 cosine 30 degrees. We know the vertical component is the opposite side on that right angled triangle. So we know that the length of that side would be 3 sine 30 degrees. If you have a look over at the heading method 1, underneath it's got the 3 Newton vector. You can see side length OA, which I have now marked in on the triangle. That vector has a horizontal component, i.e. in the unit vector I direction of 3 cosine 30, and a vertical component of 3 sine 30 degrees, as shown in the right angled triangle. Similarly, if I took the second vector, which has a force of 2 newtons, again, I could represent it as a right angled triangle. The angle being made this time is 15 degrees. The magnitude of it is 2. Again, I would then know that the horizontal component would be 2 cosine 15 degrees, and the vertical component would be 2 sine 15 degrees, which means the 2 Newton vector, which I've labelled in as vector O to vector B, is equal to 2 cosine 15 degrees in the unit vector I direction plus 2 sine 15 degrees in the unit vector J direction. The resultant sum of those vectors, that is adding the two vectors together, what we would do would be to add the two I components, 3 cos 30 degrees, 2 cos 15 degrees, that are both operating in the direction of unit vector I. They are added together. So we get 3 cos 30 degrees plus 2 cos 15 degrees in those brackets in unit vector I direction. In the J direction, we have 3 sine 30 degrees and 2 sine 15 degrees. We add those two together, and they are going in the direction of unit vector J. In specialist maths, of course, we normally would do exact values. In this example, I am not. 2 cos 15 degrees is an exact value, just as 2 sine 15 degrees is an exact value. Evaluating them will give us decimal approximations. Hence, 3 cos 30 degrees plus 2 cos 15 degrees comes out to be 4.53 in the direction of unit vector I. 3 sine 30 degrees plus 2 sine 15 degrees comes out to be 2.018 in the direction of unit vector J. So it says find the magnitude and the direction. So the magnitude and the direction. Just to visualize what is happening, what we have is another right angled triangle. The magnitude of R, I'm just going to write as R, is the length of that hypotenuse. We know 4.53 in the I direction will be our adjacent side, and we know 2.018 in the J direction will be our opposite side. And it is the angle between the hypotenuse and the horizontal side that we need to find the angle of. So, being a right-angled triangle, we want to find the magnitude of vector r, or the length of the hypotenuse. So it's the square root of 4.53 squared plus 2.018 squared, which comes out to be 4.96. Now remember to include the units, so 4.96 newtons. The angle, tan theta, equals the opposite side divided by the adjacent. Tan theta equals 2.018. The bottom line says 24.012. That is obviously a mistake. It is 4.53. So inverse tan of that gives us 24 degrees and 1 minute. The second method uses either the cosine rule or the sine rule. So you take your vectors and redraw those vectors head to tail. So the 3 Newton vector, 0a, is shown. Then the second vector, OB, has been moved to the head of A. The resultant vector has then been marked in. So, angle OAB is 165 degrees. Using the cosine rule, you can see the magnitude of r squared equals 3 squared plus 2 squared minus 2 times 3 times 2 cosine of the angle between them, which is 165 degrees. That will give us 24.59. Taking the square root of that, we get that the magnitude of the resultant vector is 4.96 newtons. To find its direction, I've used the sine rule. You need to be careful when you're using the sine rule. And the reason you need to be careful is because there are occasions when there are 2 possible answers for theta. In this case, theta equals 24 degrees and 1 minute.